Okay, thank you. The impulse function, the step function, and the ramp function. Today we want to talk about sine function, sine and cosine function. And there you see the digital version in equation 3.3. Okay. Okay. Notice that our variable is not t, our variable is n. Our x-axis is n. Okay. Now, what's the coefficient? What's the coefficient of n? Folks, I'm just asking you to look at equation 3.
You mean that without omega?
All right, yes, omega. Okay. If this is analog signal, what would the equation say? In other words, I'm asking you, what is the equation?
Yes, the dash, yeah.
What is the equation of an analog sine wave? What is the equation of an analog sine wave?
It's the amplitude times sine. That is the open bracket, pi over 2 divided by the period t times t, close bracket.
Pi over 2?
No, 2 pi over the period times t, close
It
bracket.
amazes me that we could go through so many classes and don't know. What's 2 pi over the period called?
That's omega.
Yeah, little omega. So from the analog, how do we get the digital?
You little delayed, I can barely hear you.
You can barely hear me.
Yeah, you're moving kind of slow, and
I don't know why that is.
you could repeat your question, please.
Okay. My internet must be. Yes. How do I go from x of t to x of n? Do you hear me?
I hear you.
how do I go from x of t to x of n? What makes a digital signal a digital signal?
You have a specific time and specific value.
All right, what specific time values do we have? What specific time values do we have? What specific time values do we have? T equals what?
Are we looking at that graph?
Mr. Johnson, I didn't quite hear what you said.
Are we supposed to be looking at something, or are you just speaking? You read that?
You don't see my writing pad? You don't see my writing pad?
I see the book. I see the book and the calculator.
Okay, I'm back.
I see the writing pad now.
Can you see my writing pad?
Yes, sir.
All right. What specific t values do we use? Uh, What specific t values do we use? T equals what?
I could.
T equals NTS. What is TS? What is TS?
Yes, it's the period, right?
Period of what?
That's the period of the signal.
Period of what?
The signal.
No. No. TS is the sampling period. The sampling period. Okay. So X of T then becomes X of NTS, A sine omega NTS. Okay. And we drop the TS because it's understood the TS has to be there. Omega is 2 pi f, and TS is 1 over fs. So clearly omega is 2 pi f. So f is the analog frequency.
But I got it.
You may have to switch your provider to start right to the next one.
But I got it.
Yes.
I can't really hear what you're saying. You keep cracking up.
Yes, Mr.
I think.
All right. I'll switch providers.
Yeah.
Oh, on the screen, it's still showing like you're writing something.
Okay. Can you hear me better?
Yes, sir.
Okay. Good. I don't know how much you heard, so let me repeat what I said. Here's the analog signal. How do we change this analog signal into a digital signal? We sample. So that means what? What does sampling mean? We take in specific values of t. What specific values of t we take in? N, Ts, where n is an integer. Ts is sampling period. So we have x of t replaced by x of NTS, or we have t replaced by NTS. We shorten the left-hand side to x of n because the TS is understood. And then TS here is 1 over FS. Omega is 2 pi F. Therefore, capital omega, the digital frequency, is equal to 2 pi F over Fs. This is relating the digital frequency to the analog frequency. Learn this formula. You must know it by heart. The digital frequency is 2 pi F divided by Fs.
Got it.
Yes.
Okay, you see the box which you have on the paper. So the arrow coming from the F in the numerator, that's the analog. Okay. And that's the formula for the whole formula, the 2 pi F over Fs is digital frequency period formula.
Young man. Digital period has got nothing to do with the digital frequency. The sampling period has nothing to do with the digital frequency. Any other questions? What's the maximum value of F? What's the maximum value of little f? What's the maximum value of little f? I don't know why you folks don't know this. I don't know when you intend to learn it. If you're sampling a waveform with a sampling frequency of Fs, what's the highest frequency can you have? What's the highest analog frequency you can have? Wow.
I mean, I want to say Fs over 2, but
Well, why don't you say it?
all right, it's just the sample frequency over 2.
Thank you very much. We learned that when we were talking about sampling.
It's got to give somebody else a chance to get it wrong too, man.
I don't know why. So what's the maximum value of omega? Omega max is how much? Omega max is how much?
So it'll be the same 2 pi times fs over 2 over fs.
Which is how much? Mr. Beauchamp, how much is that?
I do it right now. I get it right down. I'll just be, oh wow, that's pi.
Pie, yes. Pie apples. Pie apples. What's the unit of pi? What's the unit of pi in this context?
That should be Hertz, right?
Really, why? You don't see that Hertz cancels Hertz? You don't see that?
Yeah.
Pi radians. Pi radians. So now you learned something. Omega for analog is radians per second. For digital, the digital frequency is in radians. Radians. So the units of frequency are different if you're talking about digital or whether you're talking about analog. Okay. So that's one difference. Let's get a snip and go to another page. So omega is digital frequency. And radiance. Omega is analog frequency in rads per second. And omega equals 2 pi f over fs. Now, here's another difference. An analog sine wave is always periodic. Always periodic. All right. What do you notice about the sine wave on the left? Is it periodic or not periodic?
I mean, it want to look periodic.
Yes, it's periodic. When does it? And after how many samples does it repeat itself?
After 10, look like
Really? Please count.
1, 12.
What do we make?
Really?
You mean repeat it? Dust sticks? Look like dust sticks right here. 1, 2, 3, 4, 5, 6.
Usually like
It starts here at 0. Starts here at 0, and it starts to repeat at the other 0. Don't you see that? So that's 1, 2, 3, 4, 5, 6, 7. The period of the one on the left is 7 samples. 7 samples. That's the period of that sine wave. That digital sine wave. The period is 7 samples. What about the one on the right? Is that periodic?
no, sir.
No, it's not periodic. Now, how can we tell? How can we tell if a digital signal is periodic? Well, for a digital signal to be periodic, we must have this to be true. This is saying the digital period times the sampling period must be equal to M is the number of analog periods. M is the number of analog periods. And T is the period of the analog signal. So this equation must be obeyed. So we have N sampling periods for the digital must be equal to M periods of the analog period. Okay. Just rearranging that, N over M must be T divided by TS. And T, of course, is 1 over F. And TS is 1 over Fs. So N over M equals Fs over F. Okay, so let me write that out. So N over M equals Fs over F. So put that. And we recognize this as 1 over omega. See it right here? Okay. So digital sine wave is periodic if it can be written as N over M, integer divided by integer. If 2 pi over omega, so 2 pi over the digital frequency, Excuse me? What's supposed to cancel out? The 2 pi over the digital frequency it doesn't supposed to cancel out. I'm saying it's an integer divided by an integer. In other words, it's a rational number. That's all I'm saying there. Where do you see it cancels out? No, all this equation is saying, take the digital frequency, okay, divide 2 pi by it, and you must end up with a rational number. That's all that is saying. Let's do an example. Same example, okay? I'm going to the next page.
That arrow to the bottom saying digital frequency.
Yes.
All right.
Goodness. So we had x1 of n. That's the sine wave on the left. With sine and 4 pi over 7. So what's the digital frequency? What's omega equal to? What's the digital frequency equal to?
Is that 4 pi over something?
That's 7. I don't know why you can't tell it's 7. So the digital frequency equals how much?
4 pi over 7?
4 pi over 7 rods. All right. So let's apply a rule. The rule is what? 2 pi over omega. So that's equal to what? N over M. That's a rational number. Where N is 7, M is 2. So my digital period is 7 samples. Digital period is 7 samples. All right. I need 2 analog periods. So it's periodic. It's periodic because it's periodic. Because N over M is a rational number. Let's take the one on the right now. Right, this x2 of n equals sine and 1307. What's the digital frequency?
17/7.
Okay, digital frequency is 13/7 radians. I don't know why you're not giving me units. Okay, so here's the test. 2 pi over 13 times 7 equals 14. 14 over 13 pi. This is not a rational number. Not a rational number. Hence, x2 of n is not periodic. Any
That's
questions
all right.
about it? Yes.
You see on the right side, omega equals 13/7. Is that rod or rod? I don't know.
Well, it's more than one rad, isn't it?
All right, then, because I had to make a note that analog is radians per second, and then digital just rod. I I wanted to make sure.
This is not saying rad per second.
All right, yes sir.
That's rads. No per
Okay.
second there.
Yes sir.
Okay. All right. Let's do another example. Folks, I want you to burn this into your head. See this? I want you to burn this into your head. Because when we start talking about filters, we can come back and we won't have to use that again. T in the continuous time domain equals n times Ts. Burn that in your head. Burn this into your head. Let's do another example. All right. Send me by chat. Example 319. Is this periodic? Send me your answer, yes or no, by chat. I see one answer. Mr. Anson, why did you send your answer to everybody?
Oh, sorry, I was supposed to send it only to you. That was a mistake, sorry.
All right, let's do it. I don't know why I don't have 7 people sending me answers right away. The rule is very simple. Is x of n equals cosine 2n. Clearly, the digital frequency is 2 rads.
Yeah, I did omega as one. So
I don't know why you did that. I don't know why you do that. Omega is a coefficient of n.
when I say I did it once, I mean I put something in front of the n, so it was
Yeah,
two pi
there is
over
some.
one times one, and eventually it became 2
Yo,
pi.
man, you make your life way too complicated.
Ever.
Omega is a coefficient of n. Clearly, the coefficient of n here is 2. Nothing else to be said. Now we test the series periodic. 2 pi over omega equals 2 pi over 2, which is pi over 1. This is not a rational number. Not a rational number. So, not periodic. And Mr. Buchap, I have no idea why you said yes. Quickly, send me what x of 0 is. In chat, send me what x of 0 is. Folks, what is it? Okay. I don't know what you just sent me. Mr. Johnson? Because that's not a question I asked. I asked, what's the x of 0? Somebody else, please. Wow. This tells me you folks are not studying. That's what this tells me. This tells me y'all are doing the teamwork, but you're not studying. Well, all I can say to you is good luck to you. Where we have n, we put 0. That's all that means. X of n equals cosine 2n. Where we have n, we put 0. X of 0 equals cosine 2 times 0.
Which is 1.
Which is cosine 0, which is 1. Don't tell me that now. Why couldn't you figure that out?
True.
Send me x of 1 in chat, please. Send me the value of x of 1. I got one answer that involves pi. No, I have no idea where this student got pi from. There's not a pi in that equation. Not a pi in that equation. Again, you all don't know math 167. You don't know math notation. All right, please pay attention. X of 1 is cosine 2 times 1. This means n equals 1. So where you see n, put 1. So this is cosine 2. And cosine of 2, remember this is in radians. Cosine 2 is negative 0.4161. Last one. Send me X of 7 in chat. Got it? Pay attention, please. Cosine 2 times 7 equals cosine 14 equals 0.1367. Any questions about that? Okay.
Hey, Dr. Kadri,
Yes?
your calculator in radians or something?
Yeah, man. I said that 5 minutes ago.
Oh, my apologies.
It has to be radians. What's the unit of n?
Rads.
No. The unit of n is not rads.
Rads per second.
No. There are no units. There are no units to n. N is 1, 2, 3, 4, 5, 6, 7. 2. 2 is rods. Rods times no units equals rods. Cosine of rods. That should be self-evident, but nonetheless, I said it a few minutes ago. You got to use rods. Now let me see what you do with this. Let's try this. Send me x of 0. Send me x of 0.
Is that a cosine?
Yes?
All right.
Miss Buchamp, that's not a number. Your answer to me is not a number. Please send me a number. Thank you. Anybody else?
I'll try. I send it to you right now.
Mr. Johnson. Mr. Johnson. Is X of 0 a digital frequency? Is X of 0 a digital frequency, Mr. Johnson?
I'm not sure. I'd assume not.
It's not a digital frequency, so why you give me the units rights?
Is X a 0 an analog?
I don't know what you mean if it's analog. X of 0 is X of n is a digital signal. So how is X of 0 analog?
So what unit should I have put?
None.
Okay.
Besides the fact that you got it wrong, you got the numerical answer wrong. I don't know why y'all can't simply substitute one number for another number and get the right answer. This is a high school question. This is high school trigonometry. Please pay attention. Clearly, we got to use cosine of 45 degrees. And cosine of 45 is 1 over root 2. 5 over root 2. Why is that hard?
You forgot a root in the numerator.
Excuse me?
You forgot to add a root 2 in the numerator.
No, I didn't.
All right.
What you thinking about is root 2 divided by 2. That's not what I wrote. Root 2 divided by 2 is 1 over root 2.
Yeah, I was thinking it was something different.
Send me x of 1. Send me x of 1. Mr. Higgs, you're right. Mr. Johnson, you're wrong again. Please pay attention. You know, we did all this back in 120. When we were plotting cosine waves in 120, I told you what you have to do in this case. So this is 5 cosine 3 times 1 plus 45 degrees. But the thing to note is, this is radians. That's radians, this is degrees. You can't add apples to oranges. You can't add apples to oranges. So you either convert the rads to degrees or the degrees to rads. So I'm going to do rads to degrees. 5 cosine 3 times 180 over pi plus 45 degrees, which would be 5 cosine 216.9 degrees. Which is negative 3.999. Any questions about that? And that's high school math. That's high school trigonometry. Any questions about this?
Yeah, just depending which one we converted in. If we converted in rods, our calculator have to be in rods, and if it converted in degrees.
Yes. If your argument is in rads, then your calculator has to be in rads. If your argument is in degrees, then your calculator has to be in degrees. Again, high school trigonometry. Certainly we did it in 120. All right. I really thought I'd get farther today. Okay. So let me now look. Let me now look at what I sent you last night, I think it was. Midterm exam. Okay, that's not last year's. You can now do question 9 of the midterm I sent you from last year, except for part 5. Except for part 5. Okay. I hope you're working these problems.
Could you repeat yourself, Doc? Cartwright? You did. I didn't catch what you said.
Why not? Because you weren't paying attention? You were reading your text?
No, I thought I got kicked out of Zone just now. I don't know what was happening on my computer.
I said you can now do question 9
Yes, sir.
of last year's midterm, except for 9.5. You can't do 9.5. Right. So you can do the first 9 questions except for 9.5, 9 part 5. I also said that I hope that you're working these questions because I'm not going over them. That's your review job. All right. Now I have to move on. Yeah, that's all the work I want to do. That's all the work I want to do on. What am I missing? Somebody dropped out. That's all the work I want to do is sine waves, digital sine waves. The rest is up to you. Now we move into chapter 4. Okay. If you will recall, we're now moving to digital filters. We're now beginning work on digital filters. If you recall at the beginning of this course, I said digital filters, analog filters are described by differential equations. And digital filters are described by difference equations. And I will give you an example of a difference equation. So generally, y of n is the output. Y of n is the output. Y of n minus 1 is the output delayed by 1 sample. Y of n minus 2 is the output delayed by 2 samples. This could go on forever. And that's equal to B1 x of n. That's the inputs. That's the input signal. X of n is the input signal. Okay. We could write this succinctly as that's the left-hand side. This equation here is a general difference equation. Let me give you an example. 2y of n plus y of n minus 1 equals 3x of n. Clearly, that's a0, and a1 equals 1, and b0 equals 3. We can rewrite this as, and usually we do, y of n equals y of n minus 1, okay, negative a half, plus 3 over 2 x of n. This is a simple first order difference equation. Why do you think it's called first order? Why do you think it's called first order?
Because it don't go any higher than A1.
All right, another way of saying the same thing is the delay is only by 1. The maximum delay is by 1. The maximum delay is by 1. We could draw a little diagram of that. Here's y of n. Here's the delay by 1. I'm going to write that as z to negative 1. All that means is delay by 1. Okay. And right here would be y of n minus 1. Okay. And I'll have a coefficient here of negative a half. Okay. This goes up here. And this is x of n, my input. Okay. Negative a half. So right here would be negative a half y of n minus 1. What do we call that? What do we call that in 410? First of all, do you agree that this is saying y of n equals, 3/2 x of n, sorry. I need a gain here of 3/2. Okay. Let me redraw that so it won't be so flooded. Here's x of n. Here's 3/2. Here's 3/2 x of n. Okay. this plus, this plus, this negative half. Sometimes we draw this a triangle. And here's the delay. Here's delay. So here's y of n. This is summer. Okay, so this would be y of n minus 1. And this is a negative half y of n minus 1. Okay. Can you not see that this diagram tells you exactly what the equation is telling you? Is that not self-evident? In digital, it's really easy to create this delay of 1. Really easy to create this delay of 1. Not so much an analog. To create a delayed signal in analog is really hard to do. But in digital is really easy to do. Because this would be a digital word. Y of n be a digital word. You simply pass it through memory. You save it in memory on the first sample, and on the second sample you read it out of memory. Okay, I'm sure you all talked about memories in 230. Any question about this diagram? Well, I hear no questions.
Am I able to see page 6? They got it, thank you.
Okay. Now I'm going to do the sample. I'm going to do this sample. Example. It's 8. And I have y of n equals 0.5, y of n minus 1 plus x of n. Okay. So part A of this question says, identify the coefficients A and B. Well, you need to get all the y's on one side. Okay. And it's clear A0 is 1. It is clear A1 is negative 0.5. It's clear B0 is 1. Sometimes we write this as a vector. Our A vector is simply 1, negative 0.5. And we'll do that in octaves. And our B vector will simply be 1. This is a recursive filter. This is called a recursive filter because the output depends upon a previous output. So when that's true, when the output depends upon previous values of the output, it's called recursive filter. Now I'm going to make my x of n. I'm going to make my x of n this function. Here's my input. This is my input. What's the equation of x of n? What's the equation for x of n? Nobody can tell me the equation of x of n.
Are we doing something like the last week? It was a unit step function or something like that.
Well, what's the equation of x of n, Mr. Buchamp?
That's U of n.
X of n equals u of n. So I didn't have to give you this graph. I could have simply said to you x of n equals u of n. I'll be conveying the same information to you as the graph is conveying. So here's my difference equation. What's the difference equation doing? It's relaying how the output is related to the input. So what's y of 0 equal to? What's y of 0 equal to? Folks, look at the equation circled in red and tell me what y of 0 is equal to.
That'll be 0.5 y open bracket 0 minus 1 close bracket plus x to 0.
All right. 0.5 y of negative 1, 0.5 y of negative 1 plus x of 0. I mean, why that's not self-evident again, I don't know. All right, the problem is we don't know what y of negative 1 is because we haven't been told. Therefore, we assume that it's 0. So y of 0 equals x of 0. What's x of 0 equal to? What's x of 0 equal to?
1.
1. Just look at the graph. X of 0 is 1. So y of 0 is 1. Y of 0 is 1. There's our first point on our output. Okay. What's y of 1 now? What's y of 1? What's y of 1?
That'll be 0.5 plus x of 1.
Say again?
0.5 plus x of 1.
Mr. Johnson, Mr. Johnson,
Your
why
Y
don't you
zero.
just, thank you very much. How hard is it to read what's in red and tell me what that particular value is for n equals 1? How hard is that? Y of 1 is 0.5 times y of 0 plus x of 1. So y of 1 equals 0.5 times 1. We discovered that y of 0 is 1. What's
Yeah,
x of what?
0.5.
What's x of 1?
That would be 1.
1. So y of 1 is 1.5. Very quickly, send me in chat. What's y of 2? Send me in chat. What is y of 2? It's Mr. Anderson who left. Yes, Mr. Champ, you were right. Please pay attention. No, Mrs. Stewart, you're wrong. I don't know why this is hard. Y of 2 is 0.5 times y of 1
And this is 1.75.
plus x of 2. Y of 2 is 0.5 times y of 1 times 1.5 plus x of 2. X of 2 is 1. 1.75. I don't know why that is hard. All right, we'll have to end there for today. We'll pick this up on Wednesday. Any questions or concerns before I say goodbye?
Which page of the book we was on?
This is in chapter 4.
All right.
And I don't know why I have to tell you the page of the book. Just look in the damn book. Just look in the book. Skim through it. You might learn something. All right. I hear no other questions or concerns.
See you
I'll see
later.
you on Wednesday, Lord willing.